All right, how we doing, guys? This lesson is about triangle classification. So these six terms are different types of triangles. So you got equilateral, isosceles, scalene, acute, right, and obtuse. Now these terms, you should know what they mean, or at least what they mean in some context. So we're going to review it quick. An equilateral triangle is always going to look like this. It might get twisted around a little, but it's always going to look like this. And the main property is that all sides are equal. All right? So you're going to have this side congruent to that side, congruent to that side. All right? Now, when that happens, all right, it's also going to create, you may remember this, if all three sides are equal, then all three angles are equal. All right, and since you should know that all three angles add up to 180 degrees, divide by 3, you're at 60, 60, and 60. All right? So, equilateral triangles, always, all three sides are equal, congruent, and all three angles are equal to 60 degrees, and therefore also congruent. So that's important. Now, from an application standpoint, you could be given something like, something here, and something here, right? Maybe, or and you can set them all equal to each other, or you can be told that this angle right here, as long as you know it's equilateral triangle, is equal to I don't know, 2x minus 10, and then you could take that 2x minus 10, knowing that it's supposed to equal 60, and set it equal to 60. All right, but the more important thing is knowing what it actually is. Isosceles, all right, an isosceles triangle usually looks like this, where this side and this side are the same. It could be twisted around a little bit though. All right. So technically it's at least two equal sides, but we're going to say two sides are equal. Now, same concept though. Since two sides are equals, that's going to make two angles equal. And you might remember from your proofs that if two sides of a triangle are congruent, the angles opposite them. So this angle is opposite this side, and this angle is opposite this side. So they would be congruent also. So from an application standpoint, you'd either have, again, that typical looking isosceles triangle, maybe you have A and B, and it's represented by some kind of algebraic expression, 2x plus 10, 3x minus 4, and you would set them equal to each other if you know that they're congruent and it's isosceles. Same thing here. Maybe it's C and D. So you would set those two angles equal to each other for that same reason. All right, so that's isosceles. Again, more important, two sides are congruent, which makes two angles congruent. Scalene, all right, I'm trying to draw this way. This side is not equal to this side, is not equal to this side. All right, so all three sides are unequal. All right, there's really no application to that unless you're asked to figure out maybe the angles. So same concept to carry over. If two sides were congruent, two angles were congruent. If three sides were congruent, three angles were congruent. If no sides are congruent, no angles are congruent. All right, so if you had no congruent angles, right, and you were doing some algebra to show that, you could then conclude scalene. All right, acute. Right? So you got angle 1, angle 2, and angle 3. Right? All three, remember the angle symbol, are less than 90 degrees. All right? Recall that an acute angle is an angle less than 90 degrees. Well, an acute triangle has all three angles less than 90 degrees. All right? Now, before you start to jump to a conclusion, stay with me. A right triangle. You should know that a right triangle is going to have two perpendicular sides, right? So if this side and this side are perpendicular, you make your right angle symbol in there. All right? So a right triangle is a triangle with a right angle. All right? All right. But keep in mind also, all right, the other two angles are acute. All right. Now, there's a lot of different applications to right triangles that we'll get to later in the summer, but you have Pythagorean theorem, you have SOHCAHTOA, you have a lot of things you can do in it. But once you get one of those angles to be a right angle, you know you're dealing with a right triangle. Oh, yeah. So a triangle with a right angle is a right triangle. And then obtuse, if you recall, an obtuse angle is an angle that opens more than 90 degrees. All right, so an obtuse angle is going to look something like that. Okay? And that's going to have one angle greater than 90 degrees. All right, but again, the other two angles are acute. All right, so in other words, any type of triangle is always going to have at least two acute angles. All right, if it's an acute triangle, though, it'll have three. A right triangle is going to have one right angle and two acute. An obtuse triangle is going to have one obtuse angle, right? One obtuse angle, and the other two will be acute. All right. So again, scalene, all three sides are different. Isosceles, two sides are equal, two angles are equal. Equilateral, all three sides are equal, all three angles are equal, and 60 degrees. Now there is more we can get into at isosceles. You might remember base angles, the two angles that are equal are called base angles, and the other guy is called the vertex. So there's always two, two base angles that are are duplicates, and then the one vertex angle is kind of hanging out solo. All right, so hopefully this makes sense, and we're going to end it right there. All right, so that's lesson 1.